Everyone, thank you so much for joining us tonight for a special presentation for the freshwater stewardship community. We are really excited to have Lauren Lawson here with us tonight, and she's going to be our keynote speaker. There are a few people from Watersheds Canada who are going to be able to help you out. So my name is Monica. I'm the Communications and Fundraising Manager, and I will be facilitating the presentation and the Q&A. And then we also have Nicole, who is our Freshwater Health Coordinator. She's going to be in the chat, giving people some extra links for resources and helping you out with any tech problems you have. So you can send her a private message through Zoom if you're having any trouble hearing anything, or if you have a question you want to submit for the Q&A. And just a brief introduction to Watersheds Canada and this freshwater stewardship community. So Watersheds Canada is a national registered charity that focuses on protecting our lakes, rivers, and shorelines through a number of education and stewardship programs. So you can see a couple of examples on the screen here. We work with property owners, community groups, different organizations, and students to lead on-the-ground restoration education programs. So some of the examples you can see in the top left is our fish habitat restoration program. You can see some brush bundles that are being built on shore, and then they are deployed back into the water to restore in-water habitat for fish. And another restoration project we have is called the Natural Edge, which is our top right photo here, where we use native trees, shrubs, and wildflowers to restore shoreline properties. And this can be done on individual shoreline property and private property, but also with demonstration sites like public parks and boat launches. In our bottom left corner here, we have the Love Your Lake program, which is delivered and coordinated by Watersheds Canada and the Canadian Wildlife Federation. You can see a little binder, perhaps, depending on the device you're watching this on, and it is an assessment program for shoreline properties, going through a number of different factors found on the shoreline and giving an assessment for that property specifically so that different recommendations can be made to protect lake health. And so this is all private and confidential and customized to that shoreline property so that they can take actions for their freshwater health. And one of our newer programs in the bottom right there is the Nature Discovery Programming, which focuses on getting kids outside and equipping classrooms and families and grandparents with different resources to have nature-based exploration and learning about local species and how you can make a difference for them. So all of those are kind of a brief overview of our programs. As we are a national charity, we do not receive any regular funding year after year. So we really rely on these community partnerships and the donations from individuals and granting organizations to support them. And if you would like to support Watersheds Canada, you can do so at watersheds.ca/donate. All donations are tax receivable in Canada, and you can help ensure these programs continue across the country to protect our freshwater health. And another one of our programs, which is the one that we're here for tonight, is the Freshwater Stewardship Community. So this was launched in response to the pandemic. So in 2021, we were able to reach people across the country and provide them with resources and networking opportunities so that they could learn about different freshwater topics and also be equipped with tools so that they could take action to address different problems they were seeing taking place in their community. So since 2021, we have hosted 25 webinars and created 19 handouts, which act as summaries of those presentations, really great resources if you have AGMs or mailouts that go through your community group, or if you just want to post it on a website or your social media page, you can do so. All of those webinars, handouts, free for you to use and share with anyone that you think could benefit from it. And there are a wide variety of topics. So I encourage you after today to go check out that website. It's where you probably registered for today's event. And if you scroll down on the page, you can see where all the archived content is. And speaking of upcoming events, we have an invasive species mini-series happening in a week and a half. So if you are in an area that is affected by any of these specific invasive species, we encourage you to tune into these webinars. We have one about garlic mustard, one about water soldier, and one about grass carp. And so these will be happening in a week and a half's time. All of them will be recorded. So if you can't attend it during the daytime, I encourage you to still register, and you will get the recording and the resources that are created from those webinars. And you can do so at the website watersheds.ca/freshwater-stewardship. But for today, we are going to be talking about road salt. So I'd just like to introduce Lauren Lawson, who is our speaker tonight. Lauren is a PhD candidate at the University of Toronto and holds a BSc in Environmental Science and Conservation Biology from the University of Toronto. She is an aquatic ecologist researching how cities impact freshwater organisms. Through her work, she brings attention to nature in cities and seeks to protect Canadian freshwater ecosystems, even in highly urbanized regions. So Lauren, whenever you are ready to go, you can start.
Okay. So hi, everyone. Thank you for joining tonight. My name is Lauren Lawson. I'm a PhD candidate at U of T. A large portion of my PhD thesis focuses on different issues surrounding road salts and chloride in relation to ecological impacts and species at risk. And tonight I'll be talking about salting our freshwater ecosystems and understanding the consequences of road salt use in Canadian watersheds. Road salt has been in use since the 1930s, with the first experiments on salt as a de-icer taking place in 1938 in the state of New Hampshire. By 1941, about 5,000 tons of road salt were used annually in the United States, and in more recent years, the US has used about 10 to 20 million tons of salt annually, and in Canada, we use about 5 to 7 million tons of salt per year. To contextualize this large amount of 5 to 7 million tons, this is equivalent to about 35,000 blue whales. And de-icing salt works by lowering the freezing point of water. So water normally freezes at 0 degrees Celsius, but by introducing salt, the temperature at which the water actually freezes can be lowered. And for rock salt, the temperature it can melt up to is about -9 degrees Celsius. And after that, it becomes less effective at actually melting ice. Different types of road de-icing salt have lower freezing points. For example, calcium chloride can be effective up until -31 degrees Celsius, but it's also very expensive. And the most commonly used type of salt is rock salt or sodium chloride, which is essentially the impure form of the salt that we keep on our dinner tables and at our houses. And we use salt for several key reasons. And the first reason is that we are de-icing our roads is to increase the safety of wintertime transportation. We also use salt to maintain safe conditions so we aren't liable for others getting injured potentially on our own properties. And rock salt is the most common salt used in many areas because of its low cost, although its effectiveness is really dependent on local temperatures and conditions. Finally, I personally believe that we use a lot of road salt as well because salt can be considered one of those out of sight, out of mind pollutants because road salt flushes away off of our roads when it's diluted by melting snow or rainwater, which means most people don't think about road salt after snowstorms or ice storms. Now, there are two main user groups for road salt, one being public users and the other being private users. And on a public level, large organizations like municipalities, provinces, and transportation organizations are responsible for salting public roads, transit lines, some parking lots, and in some cases, sidewalks. On a private level, homeowners, renters, and business owners salt private roads, driveways, and private property, as well as sometimes their own sidewalks. While the use of salt has become almost universal, it's only in the last few decades that the many impacts road salt can have, both on humans and the environment, have really begun to become recognized. And road salt can impact humans directly through impacting infrastructure like our bridges and our roads, as well as our private vehicles. It can also directly damage our private property like our pets' paws. It can damage our shoes, and it can also damage our flooring in our home as we track salts inside. And salt also can have large impacts on our drinking water and actually contaminate our drinking water sources. High chloride concentrations are attributed as one of the causes of the Flint, Michigan water crisis, as the city of Flint actually switched their water source from a lower salinity water source to the Flint River, which had higher chloride concentrations. And what that meant is that the chloride actually caused leaching of metals and lead into the pipes that delivered drinking water to these homes. And while road salt and chloride hasn't been deemed directly toxic to drinking water, it can lead to indirect effects like this metal leaching that was found in Flint, Michigan, and it can also change the taste of water. So for example, various provinces have aesthetic concentrations for chloride, which means that at certain concentrations, such as the New Brunswick concentration of 250 milligrams per liter, that's the concentration where if it's in your water, you're going to start to taste that your water tastes a little bit off and it tastes unpleasant. Then finally, sodium chloride in drinking water may also pose issues to those on low sodium diets. Salt can also impact terrestrial ecosystems in diverse ways. And one way is through attracting large mammals like moose and deer onto roadways. And these mammals are often salt deficient in the wintertime. So by putting salt onto our roadways, we're creating these attractive novel salt licks where the moose and deer will actually walk onto roads, kneel down and lick the salt, or even actually walk directly up to vehicles and lick salt off them, sometimes even walking into people's driveways and licking their parked cars. And this is obviously extremely dangerous for the animals themselves, but it's also a huge hazard for you drivers. As you can imagine, it would be really difficult to see a moose at night as you're coming around a corner. Salt can also be toxic to birds, and it's been shown that birds will consume small grains of salt from roadways, which can lead to actual changes in their behavior and can become toxic. Birds can also be impacted through collisions, just like larger terrestrial animals like moose and deer. Plants and vegetation are also impacted by salt, and this is a photo of a vegetation buffer between a sidewalk and a roadway. And you can see that a large die-off of grass has occurred, which can be contributed or attributed to road salts. And road salts can be directly lethal to plants and directly toxic by killing them, or they can also have sublethal effects by impacting their growth, as well as making them more susceptible to things like infection or parasites. Now, many of you listening to this presentation this evening are likely very interested in the impacts that salt can have on our Canadian freshwater systems. There's a great saying that Environmental Defense came up with of where the water goes, salt will flow. As salts are carried off by roads by snowmelt and rain and into our freshwater bodies. And the process of increasing the saltiness of our freshwater systems is considered to be called freshwater salinization, or in some cases, you might hear it referred to as secondary salinization. And we are seeing clear signs that chloride levels are increasing in lakes and rivers across North America. And this is a map here from a study from a researcher out of the University of Wisconsin, Hilary Dugan, and her team looked at chloride concentrations across lakes in North America, and they found clear evidence that chloride concentrations are increasing through time. The second figure here is from a paper I published with my supervisor as part of my PhD research, and it shows chloride data from the provincial government, which was collected over time. Specifically, this data is from a site within Toronto on the Don River. And we looked at trends in chloride since the 80s in the Toronto area. And this red dashed line here indicates the acute and chronic, well, this one, the red one indicates the acute threshold that the Canadian government has set out for a water quality guideline for the protection of aquatic life. And this is set to 640 milligrams per liter chloride. This orange dashed line here indicates the chronic threshold, which is 120 milligrams per liter. And what that means is that based on the study that the Canadian government did, it's expected that at this concentration, if organisms were susceptible to these chloride concentrations for a longer period of time, they would see negative impacts. And you can see on this plot through time at this site, we are seeing general trends of increasing chloride concentrations on this river. And this is a trend that's very common across especially urbanized rivers in Canada. We also spent the summer taking water samples across sites in Toronto, in the Toronto area, and we managed to sample 214 sites across the greater Toronto area. We found that 89% of the sites that we sampled at had concentrations that were higher than that chronic Canadian guideline, and 13% of sites were higher than the acute guideline. And this is really important because this is the time of year, the summertime, where we wouldn't expect to see high concentrations since it's not the time when salts are directly applied onto our roads. It's also concerning because the summertime is a time when many freshwater organisms are spawning and reproducing, which means that these sensitive life stages are maybe more vulnerable to the chloride concentrations that they're experiencing. Some of the reasons why chloride concentrations are becoming higher year-round and not just in the wintertime is because of the way stormwater infiltrates into our soils and our groundwater. So you can see this diagram here that depicts how our groundwater and our rivers may be interacting. And when water percolates down into our soils, salts can be stored within the actual soil systems. They can also percolate down into our groundwater systems, and groundwater can contribute a significant portion of stream flow during the summertime. So groundwater contamination may be one of the reasons why we're seeing these high chloride levels year-round. Salt can also impact the physical dynamics of lakes. So this is a great diagram from a paper published by Dupuis, which shows how salt can actually change turnover dynamics in lakes. So in many lakes, there are natural turnover cycles that occur in the springtime as well as the fall time. Whereas in the summertime and the wintertime, lakes can become thermally stratified, where you see different bands of temperature of the water as you go deeper within a lake. And there are these natural cycles, as I mentioned, in many lakes, which can be disrupted when salt enters a lake. As salty water is often denser, it can collect at the bottom of a lake and essentially decrease the zone that becomes mixed during these turnover events. And essentially what that means is that some lakes may experience longer periods of time where they have anoxic and low oxygen zones at their deeper depths. Moving into the impacts of salt directly to aquatic ecological communities, I want to start off with a framework for thinking about ecological impacts. And as an ecologist, I like to think across different scales, ranging from the stress that an individual organism might experience, up to how those stressors may be felt at a larger population scale, and then how community may be responding to stressors as well. So for example, if a fish is experiencing a stressor and needs to spend more energy on just staying alive, it may not be able to do things like eat or reproduce or even grow. And this means at the population level, there may be long-term effects that reduce overall population sizes. At the community level, this means that if sensitive organism populations are changing, there may be broader scale food web effects. For example, a predator may no longer be able to find its prey. For road salt specifically, more and more research is coming out on the direct impacts of salt to organisms. And one study by Hintz and Relier showed that fish grown in high chloride concentrations had reduced growth compared to more normal levels of chloride. And this is shown in this photo of rainbow trout here. Another study by Carricker and Gibbs showed that salamander egg masses, shown in this photo here, were much smaller when they were transported into high chloride water. And these examples get at that idea of sublethal effects and ecological nuances. And if these changes are taken up to the population level, you can imagine that over time, we might expect populations to decline overall. Salt is recognized as one potential stressor to Canadian species at risk. And this map here shows the distribution of species at risk in Canada. And you can see these dark red areas overlap with regions that we know are using a high amount of road salt and regions that are showing increased levels of chloride in their waterways. And some of my research specifically looks at how road salt might be contributing to the decline of red-side dace, which is an endangered species found in southern Ontario. Other sensitive species are also thought to be impacted, like various amphibians, like the spring peeper. And while we know there are numerous sensitive species, we also know that there are a few species which are more tolerant, like the American toad and the invasive brown goby. And this is important to recognize as road salts may be contributing to changes in the types of organisms that we will find in our freshwater systems through time. There's also an interesting dynamic that natural water conditions can play in determining how toxic salt might be within a system. It's been found that road salt can become more toxic to organisms in softer water. And this is relevant when we think about nationwide guidelines and how guidelines may not be protective enough in certain regions like Ontario and Quebec, where we know we have much softer water. The reason why chloride may be more toxic in softer water than hard water has to do likely with physiological mechanisms and ratios of ions related to soft versus hard water. But I just wanted to highlight that here this evening, since many of us are calling in from across Canada from regions with freshwater systems considered to have softer water. And this means that these systems may actually be more sensitive to road salt than others. So just to recap the various impacts of road salt, evidence suggests that road salt can have numerous impacts to our infrastructure and drinking water, terrestrial ecosystems, physical lake dynamics, as well as aquatic biodiversity. And ultimately, the science and the policy is clear on road salt. Road salt is considered a toxic substance. It's been considered toxic under the Canadian Environmental Protection Act for over 20 years now. And after it was listed as toxic, a series of road salt best management practices emerged for large-scale users of salt. Touching back on my first few slides, it's important to remember that there are, in my opinion, two different groups that are using road salt. One being public users of salt for roadways and transit, and then the second being private users of salt. At the public level, large organizations are supposed to be reporting to the Code of Practice for the Environmental Management of Road Salts. And this was a set of practices set out by Environment and Climate Change Canada after road salt was designated as a toxic substance. And some of these best practices for salt that they're supposed to be moving towards include covering salt storage areas, calibrating vehicle equipment to make sure the right amount is being dispersed on roads, checking weather forecasts and basing applications on precise weather patterns. So making sure that if there's going to be a sudden increase in temperature that, last night wasn't expected, but there's a sudden change this morning, making sure that's accounted for and we're not putting down a lot of salt for no reason. Pre-wetting materials to help them stick to the road instead of bouncing off when they're released from trucks, as well as using live veg plows, which are able to get into the nooks and crannies of roads to reduce snow and ice cover. And these organizations are doing a pretty good job at meeting many of these targets. Based on recent reports that have been published, 100% of organizations are submitting their salt use reports, 100% have effectively stored their salt and made sure that they're covered properly, and a high percentage have increased their technology on their trucks. However, there's still some gaps that need to be filled, such as the identification of key salt vulnerable areas. So those are potentially freshwater systems that might be highly vulnerable to chloride contamination. And some of our research is going to be diving into that this year. Now onto the private use of salt. This will be informative for homeowners, renters, and also business owners. At the homeowner or renter level, several key tips I have for better salt and ice management are highlighted here, and many of these tips are available from municipalities as well as local conservation organizations. So I highly suggest you look into your local organizations as well. But some key tips include shoveling first, so making sure that you can remove as much snow and ice yourself first before putting down salts to make sure it's as effective as it can be. Checking weather and temperatures to make sure that it's actually going to dip below zero before putting salt out, and also recognizing that after a certain temperature, salt might not be effective. So if it's so cold that salt's not effective, there's really no reason to be putting it out. Using the right amount of salt, and a good rule of thumb for this is to use about a pill bottle's worth for what you can think of as the average size of a city sidewalk slab. You can also sweep up extra salt. So if you notice after a storm that some salt wasn't diluted and washed away, you can sweep it up and reuse it. And this is also applicable to if you're using any sort of traction aids like sand. Another tip is to divert downspouts on your properties. So if you have a gutter or a spout entering or flushing right into your walkways or your driveways, I would advise you to divert it into a garden or onto your lawn. You can also use various traction aids like sand. Some people have actually tried to use kitty litter as a traction aid. Another interesting traction aid that you can try using is if you have a wood burning fireplace, you can actually use the debris after a fire to increase traction of the ground. And what's interesting about this as a solution is that the solution at a small scale is that the debris from fires is often usually dark in color, which means that it can actually attract sunlight too, which might help with the de-icing process when it's sunny out. I also encourage you to talk about salt. So the more that people know about these issues surrounding salt, the more we can encourage better freshwater stewardship overall. And then finally, I recommend you hold businesses accountable that you see that are oversalting. And by this, I mean that if you see in front of your favorite local store that there's piles of salt outside, I encourage you to go in and actually talk to the people working there and the business owners to let them know that you're a concerned customer. Now, at the business level, many of my recommendations are the same, except I have two separate ones. And one additional recommendation would be to check your insurance plans and ensure that you understand what the liability protection you have is, as liability is one of the main concerns and barriers to reducing our salt use. Another really interesting tip that I have for a business or a larger scale use, such as a large residential property, would be to look into using smart salt certified contractors. And smart salt certified contractors are certified through a specific program that helps snow management companies and contractors understand the right conditions that salt are required in, as well as how much is needed and what the environmental impacts are of excessive salting. And this program actually has a website where you can look for contractors in your area that are Smart About Salt certified. So I encourage you to check that out. Then finally, I'd like to touch upon the issue of liability, once again, as it's a big concern and barrier for many people in reducing their salt use. Interestingly, New Hampshire, which was the first state to actually experiment with salt, is also the first state to design a limited liability relief program for individuals certified through the Green Snow Pro program, which has a lot of similar concepts and links to the Smart About Salt program that I just mentioned. And I'd personally like to see a program like this to come to Canada, but to my knowledge, this program hasn't made it across the border yet. So overall, I have three main take-home messages for you this evening. The first is that excessive road salt has legacy effects in the environment. And this means that we need to start reducing our personal use of salt now in order to see better conditions in the future, as there's likely going to be a time lag in where we actually start to see the chloride concentrations improving within our freshwater systems. Secondly, less salt does not equal less safe. So safe conditions can still be maintained when we reduce our use through effective management practices like brining and using various traction aids, especially at the personal and private use level. And then finally, local action does make a difference. Environmental stewardship is the responsible use and protection of the environment. So I urge you to take what you've learned this evening and make a difference at a personal level, as well as within your local communities, so we can keep our Canadian freshwater fresh. And with that, I'd like to thank Monica for setting up this webinar and the team at Watersheds Canada, as well as my supervisor at U of T, Don Jackson, my various funding sources, and then of course, my department at U of T. I'd love to take any questions you have. If for some reason we don't get to your specific question, I'm happy to answer questions through email as well.
Wonderful. Thank you, Lauren. We do have a number of questions, so we'll go into those right away.
Okay.
So the first one is just asking about some alternatives. So one thought was using beet brine, and if you had any comments about if that works and if it was safe.
Yeah, so there's a lot of research currently going on looking at suitable alternatives. In my personal opinion, I don't think the science is there yet for me to suggest that everyone should be switching over to something like beet juice. And the main reason I say that is because beet juice often has organic components to it. And what that means is that those organic components, when they make their way into freshwater systems, it can actually lead to growth of algae, which can deplete oxygen within waterways. So switching from salt to something like beet juice on a large scale might actually lead to different environmental issues. And there's been some research that's shown that it might actually be more harmful. Although I won't say that I fully think that beet juice is bad. I just think that a lot more work needs to go on for looking at alternatives. And in my opinion, the first steps that we need to be taking right now are reducing our overall use of road salt before we immediately start thinking about alternatives, because there are really good other best management practices that these large scale organizations are taking that we can take note of at a private citizen level and try to adopt into our daily lives.
Okay, and then another one here about another alternative. So the person lives in a rural area that sands the dirt roads in summer as a dust suppressant. And they were wondering if you could comment on that.
Yeah, that's interesting. I have heard of some areas doing that. I don't know much about dust suppressants in general. Sand can have some impacts on aquatic organisms because what it can do in aquatic systems is increase the turbidity of water, which means like increasing the murkiness. However, sand is often also used in the wintertime in rural areas because once it gets to a certain temperature, salts aren't effective. I wouldn't say that sand is awful. I think that sand is worse in urban areas where we know that it can travel through our stormwater systems, but I know that it's commonly used in rural areas, and in some places it is the best option.
Okay, and then one more. So someone is asking from Kamloops, and they said that they were doing trials in the early 2000s with magnesium chloride. And if you knew anything about if that's still being used or if that was a safer or more harmful alternative.
Yeah, magnesium chloride, I believe, is still being used in some areas. An issue with some of the alternatives to just sodium chloride when you're using magnesium chloride and calcium chloride is it is more expensive. So many organizations don't want to pay for a more expensive option, and there still are environmental impacts. And I think it's interesting that you bring up those studies were done now 2 decades ago, because those types of studies are still going on today because it's still unclear what some of those impacts might be of alternatives.
Great. And so someone's asking if they know the salt is already in their freshwater system, is there a way for them to help limit the effects?
Salt's a really difficult pollutant to think about getting out of the environment since it dilutes into water. Really, the only large scale way that salt's going to leave our systems is through just the gradual water cycle and being flushed through our system. So there's not much you can do to get it out of the system once it's there. The main action that can be taken is trying to limit the additional amount that's being put in within your jurisdiction. So eventually that salt will make its way out. It could take a very long time, but it's important to just make sure that we're not adding more into the system that's already there.
Okay. The next question we have here are, what are the drivers and sources of higher chloride concentrations during summer and base flow conditions?
One of the main reasons I mentioned a few slides back in the beginning is the actual contamination of groundwater. So the way that water flows across landscapes is really important to consider, in that water flows through our soils and then it can make its way down into our groundwater systems. And it's been shown that groundwater is contaminated with chloride and that we're seeing higher concentrations overall in our groundwater systems, as well as in some private wells. So I would say that a main reason is for the chloride that can be attributed to road salts, inputs from groundwater.
Okay, perfect. There's still a couple more, but if people do have questions, now is the time to put them in the chat. So we have someone who lives on a gravel road with a direct culvert for the rain and the road wash overflow. And when they ask their municipality what is being used on the road, they say it's a sand calcium mixture. Is that something that is considered a good alternative from the municipality, or should they be advocating for a different alternative to protect their fresh water?
Yeah, I mean, I think that the addition of sand helps add a little bit of traction to the ground. And as long as they're not just dumping rock salt on, that's at least one step. I think that if you were concerned about your specific waterway, you might be able to, use some of the jargon of the best management practices and talking about if the waterways that you're concerned about can be considered one of the salt vulnerable areas. And I think what's interesting about road salt is that many people don't see a future where we're not using salt. It's more of a future of reducing our use. So I think understanding which key roadways might be near freshwater systems is really important to consider when we're thinking about how much salt we're using, and as you say, what type of salt we're using.
Okay, the next question is about one of your slides. I think it was in the first half where you were talking about hard versus soft water.
Yeah.
And someone was asking about the two types. So if there's different effects that you see in hard versus soft water systems.
So it's not that it's a different effect, but it can be a more severe effect. And I think what's interesting about this idea of water softness and water hardness is that it's still, it's only been a more recently identified issue that there might be differences between hard and soft water. So some suggestions that individual researchers have had is a way to actually look at guidelines and modify those guidelines based on water softness. And to my knowledge, there's a few studies that have pointed out ways to do that, but it hasn't really been adopted yet. And I think the main thing to consider with this is the fact that within these softer water systems, we might be seeing higher impacts, and thinking about the idea that this magical number guideline that some people adhere to of, let's say, 120 milligrams per liter might not be low enough for these systems.
Okay, so we'll go into the live questions now. So sailed through the pre-submitted ones. I'm not sure for this question if it's this map or the species at risk map where you had the red areas in the more urban pockets of the country. But the question was just about Alberta. So you had said that the red trend was in these urban areas where a lot of salt was used, but the question is about Alberta that doesn't use salt. So how would you account for the higher risk there?
Yeah, so this is a general species at risk map. It's not just attributed to salt pollution. It's actually not even attributed to just aquatic systems. This is just all species at risk within Canada. So there are multiple other stressors that are occurring within Alberta that may not be related to salt pollution. And this was just mostly to highlight that we do have areas with high densities of species at risk, and then this specifically Southern Ontario region.
Okay, perfect. So this question is, and you touched on it in your presentation about how when you were sampling, you were seeing really high concentrations even in the summertime. So for a water body that is impacted by road salt, do you generally expect there to be a peak after the spring melts and then it sort of tapers off? Or are you seeing concentrations that are flat even over the summer months?
So over the summer months, it's expected that they'll be, a little bit more flat, and whoever asked that question, you're completely right in that there usually is a peak as the snows melt in the springtime. However, what's a really interesting dynamic with expectations of climate change and differences in freeze-thaw cycles within wintertime, we might expect to see more peaks of chloride spiking up during the wintertime. Because if we're having these freeze and then thaw patterns, you'll expect to see more people potentially putting down more salts, which then are being flushed into our freshwater systems. There's also some interesting dynamics to think about when it comes to rain and how that might be affecting dilution patterns. But the main spikes that we are seeing are usually in the late winter as we transition into the springtime, and all of those salts that have been stored in our snow are melting off into our freshwater systems.
The next question we have is around pets. So talking about safe levels of salt or other mixtures to use that are best for pet feed.
Yeah, I don't, in my opinion, I mean, there's like the pet safe salts and lots of marketed materials, and I'm not actually sure what the specific compounds are within those materials. The most common thing that people do is to put boots on their pets. I think I have a pet too that we're concerned about. We have a lab, and we often just make sure after walks that she's not sitting and licking her paws as well, because although the salt can actually dry out their paws. If they're licking them, it can become toxic. So I would suggest just washing their paws if you are in an area where the sidewalks are blanketed in salts.
So we're back to the alternatives with some questions here. So someone's saying that their township uses sprays. Do you know of something that would be in a spray format and if it's safe or not?
Yeah, so sprays, I think that they are indicating potentially brining, which is a really good option and a really good part of that best management code of practices, in that by using brine, so it's essentially salty water, you can astronomically decrease the amount of chloride you actually need, and it sticks to the sidewalks instead of just bouncing off into local areas that are vegetated. So it's a really good option to look into brining.
Okay, the next alternative is something called thaw rocks. If you've heard of that.
I haven't. It sounds like it might have some traction aid, which is a good step to not just be using straight salt and some sort of traction aid. But I mean, there's lots of different companies that are coming out with de-icing salts, and I do think it's important. I mean, thank you for these questions about the specific companies, and I think it's important to look into the compounds that they're actually using and making sure that it's not just greenwashing going on, and that they're saying it's a pet safe salt or an environmentally friendly salt, but in reality, if you look at the compounds, it's not. So I'm not aware of all the different types of marketed materials.
Okay. The next one is just about general ones, so about arsenic, if you've heard of compounds that have that.
I haven't. I will look into that after, but I actually haven't.
That's okay. And then I think the last one here that's about different alternatives is, what about treated salt?
Like chemically treated salt, I think the question is. Those can add obviously different types of chemicals into the environment. I'm not, off the top of my head, I don't think I can fully speak to all of the different types of chemical treatments that are going on. I think that a lot more research needs to be done on every single alternative before we make a full switch to anything, though. So it'd be interesting to see what type of research and actual ecological research that's been going on. There's a lot of different types of research that can happen when testing safety levels of these alternatives. And it's great to look at studies that researchers are doing within freshwater systems, where they're actually testing the impacts of these salts on organisms and food webs to make these calls of if these are safe or not.
Okay, just a few more questions. So if anyone has burning questions for Lauren, now's the time to put them in the chat. I'm also going to have Nicole put the survey link in the chat at this time. So it's a very short anonymous survey that you can let Lauren and I know how we did tonight. And if you have any further questions or other topics that you'd like to be covered in future webinars, that is the spot to tell us. But we'll just go through these last couple of questions here, Lauren. Thank you so much, by the way, for taking the time to go through so many. This one is, well, just be honest, I guess. Someone's asking if you feel like they're ever going to stop being salts kind of taking over the water, and what this might look like long term for freshwater health.
Yeah, I think that, I mean, I'm optimistic in that I think that the large scale users of salt, they are making big progress towards reducing the amount of salt that they're using. And I think that there's a gap between the large scale users and the small scale users like us using salt every day. And then I think that gap is mostly due to not knowing how much salt is needed, and also being concerned about safety for ourselves and other people, which is a totally valid concern, which is why I think that this education component of knowing how much salt is actually required is really key. I personally don't think we're going to move into a future where there's no salt, because we do need it for safety in some aspects, but I think we can move to a much less salty future, which should help our freshwater systems in the long run. But as I mentioned, as one of those take-home messages, it is going to take some time because of the salt that's already in our environment. So we need to allow time for our freshwater systems to essentially catch up if we are going to be making any changes and reducing our actions of salting.
And then kind of building off of that, what you see maybe happening in the future, do you think the threshold of 120 milligrams per liter will ever be lowered?
I think there's scope for it to be lowered. I think these guidelines are really difficult to make in that they are set for all of Canada, which there's a lot of region specific salt issues that should be considered. So there's potential scope for even provinces that they actually should be developing their own guidelines. So I would really support an action like that. And I do think that these guidelines should be revisited in the next couple of years, hopefully, or at least talked about and understood better, in that there are exceptions to these guidelines, and understanding what these guidelines actually mean and what they're based on, because most of these guidelines and how they're built are based on laboratory tests of organisms that are tested within a controlled laboratory environment. They're not taking salt into a local lake and testing them within there. So there's lots of environmental and ecological nuances to do with those types of tests. And unfortunately, these are the best guidelines we have right now. They're a good benchmark to think about. But we do need to start thinking about what if there's other impacts at a lower concentration. And it's known that certain organisms like freshwater mussels are susceptible at lower levels.
And speaking of these thresholds, do you know of any that exist for marine ecosystems?
Not for salinity or salt. I don't think that road salt is often considered within a marine environment, to be honest.
Yeah, I think the question was thinking downstream, right? It's eventually going into the ocean. So just knowing if there were any threshold limits or numbers that people should look for when they're measuring if they live out on the coast.
Yeah, no, I don't think so. With the idea that the salt levels we're seeing are extremely elevated in many areas for freshwater, but they still are below sea level. So I don't think it would be necessary to potentially measure closer to the ocean. However, I will say that like ecosystems that aren't connected directly entering into the ocean can still experience freshwater salinization. So like coastal wetlands that aren't directly connected to the ocean can experience similar effects. So freshwater on the coast is still important, but the specific areas that are letting out into the ocean might not be as of concern.
And all I was going to add to that is there's an organization called Water Rangers. If people are not familiar with them, it's a community science platform where you can measure a number of different parameters for water quality, and they have ocean kits as well as lake kits. So you can contribute to that open source platform and see what the levels are, especially for chloride. If you're interested, you can get test kits and you can contribute to that database online, which is open source and is available for fresh and salt water in Canada. People are asking about contact information, so I just want to assure people that we will be sending out a follow-up email later next week with a summary handout of the presentation, some of the studies that Lauren mentioned, if you're interested in learning more about them. And also, if you want to share some of the action steps that Lauren outlined, you can find that all in the handout, which is going to come out next week, as well as the recording from today, if you want to share it with anyone. And we'll also put Lauren's email in there. So if you come up with any other questions or you want her advice or anything like that, you can reach out to her that way. And I think the last question here is if you know of any road design criteria that are designed to limit the salt deposits that go into watersheds.
I don't actually. I think that with roads, the main designs have to do with stormwater control and how stormwater is coming off of our roads and into the environment. And there's lots of different ways to build stormwater infrastructure. In a lot of urban areas, they're moving towards stormwater ponds, which will actually hold water. But there's a whole slew of issues that can be included within stormwater ponds when it comes to contamination and chlorides, where they can just accumulate and sit for a long period of time. So it's an interesting point. And I'm not sure if there's been much thought into how we could potentially design roads differently.
Okay, very last question here is about individual action. So someone's asking about their home water softening systems and how they have an option to use potassium chloride rather than sodium chloride. And there's quite a price differential. So they're wondering if it's actually worth it to be environmentally friendly or if the difference is negligible.
Honestly, I'm not sure. If you follow up with me, I can probably give you a better answer on that. The issue of water softeners, I think, is really interesting to raise because many people do question, what are the other sources of chloride contamination, and water softeners could potentially be one, although in most of Canada, road salts are usually attributed as the major cause of chloride contaminations. But I think that's really great that you're thinking about those types of issues.
All right, thank you for going through all of those questions, Lauren, and for your presentation as well. It was really informative and also really nice how you outlined kind of the issues, but then some actions that people are able to take. So thank you so much for giving us your time tonight and sharing all of the knowledge that you have around this topic.
Yeah, thank you for joining everyone to learn.
And like I said, everyone, you'll be getting more information next week from Lauren and I. So that summary handout, the recording, and if you have a few more minutes tonight, if you could just click that link that's in the chat to do the evaluation survey. It should take maybe 1 or 2 minutes of your time, but it's very helpful for us to know what you like about the freshwater stewardship community and also what you might like to see in a future topic. Don't forget to come back in a week and a half for our invasive species mini-series, and enjoy the rest of your evenings or afternoon, depending on where you are tuning in.